Before Bohr, we weren't really sure how electrons managed to stay in orbit around their nucleus. What Bohr suggested was that the atom had quantized energy levels around it that were the only places an electron was allowed to be in. In fact, to derive this, he simply postulated that the angular momentum of the electron has to be some integer multiple of Planck's constant over 2 pi, commonly written as h bar. He then used that assumption along with some well-known classical physics to come up with a radius of the hydrogen atom. That turned out to be correct. In this video, I'm going to try to do one better than Bohr and actually derive this postulate that he made. But first, the basics. So, imagine we have some electron around a proton and it's in circular orbit undergoing circular motion. So basically the hydrogen atom. That means there must be a centripetal force acting on the electron, and of course we know that the centripetal force is coming from the electrical force given by Coulomb's law. So we can just equate those. We can even plug in the values for the charges, since one is a positive elementary charge and the other is a negative elementary charge. We can also go ahead and cancel some r's on both sides. Now we have the equation k times the negative of the elementary charge squared over r equals mv squared. I think it's fine if we just look at the magnitude of the force, so we can take the absolute value of both sides. Now all we need is what the velocity of the electron is. So let's set this equation aside for a minute and come back to proving Bohr's postulate using the Broglie wavelength, which I justify in another video, which should be appearing above right now. The idea that Broglie pushed was matter waves. That is to say that particles are actually wave-like. If that were true, and it is, then getting waves in an orbit seems like a weird idea. Unless you use standing waves to just fit the waves around the circle. In that case, the circumference of the circle would have to be an integer multiple of the wavelength of the electron. Then we can just substitute in the expression for the Broglie wavelength into lambda, and rearrange for the angular momentum mvr by multiplying by mv on both sides, and dividing by 2 pi. Look at that. Out of de Broglie's assumption of matter waves comes Bohr's postulate of quantized angular momentum. Now to use this to get to the radius of the hydrogen atom, we have to rearrange for v, which we're going to take back to substitute into our first equation. So v is equal to n, which is some integer, times h over 2 pi over mr, which is equal to n times h bar over mr. And let's just go ahead and plug that into our first equation and expand out that squaring function. So we can see that some m's cancel and r cancels on both sides, and now we can rearrange for r. As someone who prefers theory, I'm going to leave plugging in the numbers to you, but I'll let you know that you should end up with around 5.3 times 10 to the negative 11 as the radius of the hydrogen atom. Alright, that's the main idea behind Bohr's model, which admittedly was soon set aside for a stronger model invoking wave functions. But, as I said in the last video, this is a great stepping stone to full-blown quantum mechanics. So thank you for watching, and bye-bye.